Welcome back to Programming Merit Badge for Troop 97. This is part 2 in the series, and in this part we're going to be looking at some of the applications of programming in different industries, as well as some of the different programming constructs. So let's get right into it. Just as a refresher from yesterday, we'll take a look at what the expectations are, and then we're going to get into requirements 3A on programming languages and requirement 3B on programmed devices, and then we are going to take a look at writing and debugging a program. So stick with me, and we'll get to do a little bit of coding towards the end of this and actually make a real-world a mock of a real-world program that you can then design and continue to build on. As a reminder from yesterday, we'll be expecting that you'll be filling out the Programming Merit Badge workbook. The Programming Merit Badge workbook is available on the Dropbox and can be supplemented with other written paper or Word documents that you want to include if there's additional details that you can't fit on the workbook. And again, the code that you'll be working on here does not need to be transcribed onto your Merit Badge workbook, but you can definitely point to the code if it's on one of the shared resources that I'm going to be using. You can share those with me, and I'm happy to take a look at it and see what you've done. So let's talk a little bit about programming languages. Programming languages have been around for decades now, since the 60s, when we were building programs on some of the programming languages that we talked about in our last lesson, such as COBOL and Fortran, to some of the later, more robust programming languages like C and C++, and into some of the more modern programming languages like Java and Go, and some of the different interpreted languages like Python and JavaScript. So what I'd like to talk about is what some of these different programming languages do and what their purposes are and why you might use one versus another. So we talked about some of these languages in our last discussion, but we'll go into a bit more detail on them now. So we have really three types of programming languages: those that are compiled programming languages, interpreted languages, sometimes called scripts, or markup languages. Compiled programming languages are basically applications that are written and then are run through a compiler on the computer, which will turn that program into an executable. Executable means that it's something that can run independent on a machine. This is generally what we build when we use systems like C++ and C#, and there's also a lot of the programming languages from the mainframe days like COBOL and Fortran are all compiled languages as well. The advantage of compiled languages is that they're much easier to debug. They oftentimes have access to low-level memory in the computer, which makes them very efficient, a lot of times games, and very complex graphic applications that have to do a lot of processing, that need access to the processor, that need access to a lot of memory, are going to be written in compiled programming languages, whereas interpreted languages are languages that can be run on the fly, as they say. They can run without having to go through a compiler. Now, the advantage of this is a scripting language can be run anywhere, because you can take the code and run it through an interpreter as long as the interpreter is supported on the particular machine or operating system that you're using. That script can then be executed anywhere on anybody's machine. This is what made JavaScript such a popular language, in that you can run scripts in the browser on anybody's machine. And Python is also a scripting language that allows you to run your scripts on any machine. So it's become very popular with research and machine learning and heavy data processing. In addition to that, we have markup languages. Markup languages are things like HTML. Basically what HTML is a way of creating structured documents. So they don't really have any sort of functionality. They can't really, they don't need to be compiled, because they're really just a static document that has a particular structure to it. Another example of this is XML. They're basically just ways of representing a document in syntactical form. Now, when you're working within any one of these programming languages, it's very important to be able to actually plan out what it is that you're going to write. And we can take a look at a couple of different examples here of how you can plan out an application. One of the most common ways of planning out an application is to use a flowchart. A flowchart basically puts boxes on the screen that you can use to determine what an application should be doing next. And we're actually going to take a look at a flowchart in our example later on, so we can go into what some of the different shapes represent and how you can use them to plan out the logic of a program. Another way of writing programs is using pseudocode. Pseudocode is basically writing your program out in plain words. So you can see this example is writing some pseudocode for a robot that tells it to move forward, read wall sensor, found wall. So this is written in the same procedural format that we would write code that we would program into a computer, but it's written in plain English. So it allows us to write out our program before we actually translate it into the syntax that the computer can understand. And then the last one is the state diagrams. State diagrams allow us to look at a different component of an application and look at all of the different states that that can be in. So remember when we talked about binary and about the way that computers are programmed, everything is programmed through on and off, ones and zeros. Those are represented by state. So anytime you have something within your application, it can either be on or off. It can be set to one value or another. And state diagrams allow you to map that out. We won't be writing any state diagrams, at least not in this lesson. We might take a look at them later on if the need arises. Lastly, I want to talk about some of the different control structures and components of an application. And this is another thing that's going to differ from application to application. Every programming language is going to have its own requirements for how control structures are built, what type of conditional operators it has, what type of data structures it has, and what type of arithmetic operations that it has. So some of the syntax that you're going to see here is going to vary from language to language, and some of them are simpler, some of them are more complicated. Definitely in a programming language like C++, where you have strict control over the memory, and Java, where it's a fully object-oriented programming language, there's going to be a lot more variations on control structures and arithmetic operators for you to be able to do things like managing memory versus a scripting language like Python or JavaScript, where it's going to have a smaller subset of those, but again, much easier to work with. And we'll actually be looking at some Python later, so you may recognize some of these different control structures when we get there. So control structures, really the two big ones that you're going to come across in any programming language are loops and conditions. Loops are basically any time that you need a program to do something over and over again. So if you have a program that waits for some user input and then does something with that input and then has to wait for user input again, which is just about any application that you can build, that application is going to be in a loop. It's also going to be used if you want to count things. So if you have say you're building out a game and you want to count all the sprites on the screen at a given time. You want to be able to maybe apply some artificial intelligence algorithm to make each one of them do some action. You can loop through all of the characters in the game and make them each perform an action before you get back to the first one and start all over again. Loops are critical in applications because just about every application is going to need to do some repetitive tasks. Really, that's the purpose for using computers to is because they are very good at doing repetitive tasks. If the tasks that we were doing weren't repetitive and we can just write everything out sequentially, it would really defeat the purpose of even writing a program to do it. So loops are critical in that they allow us to use a computer to do exactly what it is that they're effective for, and that is doing calculations over and over and over again. Conditions are oftentimes you'll hear them called if then else. Basically what they do is they give you the ability to look at a variable that we've stored. So we talked a little bit about variables yesterday. Variables are storage units within your application that you can use to recall some piece of information later on. Conditional operators allow you to take those variables and compare them against different things. So if you, for instance, wanted to build out a website for a car dealership and you wanted to display only sports cars, you could put a condition in there that said if car type equals sports, then display, else hide. And then if they switched it to pickup trucks, you'd say if car type equals pickup, then display, else hide. And that will give you a condition that will only display those cars that are relevant to what the user is trying to look for. You can also use other conditional operators like not equal to or less than or greater than. So we can have a good deal of control over what we're presenting to our users. So speaking of that, in order to be able to perform those if then else, we need different conditional operators. And I just mentioned a few of those now. Those are your equal and your less than and your greater than, your less than or equal to, your greater than or equal to. One thing I'm going to note is that you'll see the equal is actually two equal signs. This is pretty common in programming languages because usually the equal sign is designated for variable assignment. So if you are using an equal sign, you're usually telling the program, take this value and make it equal to this. Whereas when you're trying to do a condition, you're saying, is this value equal to this other value? So again, these are just syntactical things that you learn and are going to vary from program to program. You'll see some languages actually use triple equal signs and exclamation point equals for not equals to, and it's really important to learn the syntax of whatever it is programming language that you're trying to use so that you can make good use of the operators that you have available to you. In addition to conditional operators, we have arithmetic operators. Again, computers are very good at doing arithmetic. So we have the ability to add, subtract, multiply, divide, and then I added a couple more in here, plus plus and minus minus, just because I wanted to give you an example of what some of the other operators that are available in programming languages are. So a plus plus, if you were to take a variable and add a plus plus to the end of it, what you'd basically be saying is take whatever value this is and add 1 to it. Same thing with minus minus, you'd be saying take whatever variable this is and minus 1 from it. So if you were writing an application that was managing the stock of some product that you were selling, and that product was going to be depleted every time somebody purchased one, when they would say it was a bar of soap, you'd say bar of soap equals 10, meaning that you have 10 bars of soap in stock, and then somebody buys one, you would say bar of soap minus minus, and your value for bar of soap would now be down to 9. and you can use these operators to increment and decrement. And this is incrementing and decrementing becomes very important in programming, especially when you're dealing with loops. So for loops tend to require you to step through, iterate through, and continually increment values so that you can keep track of where you are within the loop. So just a couple of examples of arithmetic operators that you would come across when you're programming. Lastly, I just wanted to make mention of data structures. So every programming language is going to have data structures. Some have arrays, some have tuples. There's a variety, some have objects, and these different data structures are used for storing information that is more than just a single value. So we'll talk a little bit about arrays because arrays are probably the most common. Basically what arrays are lists. They are a grouping of a bunch of different values. So if you had, say, you were writing a program to handle a roster for your classroom, that roster would have 25 children in it. Each of those children would have a name, and they would be listed in an array. So it would be students equals Joe, comma, Bill, comma, Sally, comma, Beth, comma, etc., etc. So you can just store all of the students' name in this one variable, and then you can reference them by the index that they're in. So Joe is the first one in the array, so he would be the first array index, and Bill would be the second, so he'd be the second array index. Sally would be the third, and so on and so forth. So you can reference any one of the students by their specific placement within that array. So just really important to understand that we have these data structures and they're available for use when you're trying to store large volumes of data. Next, I want to talk a little bit about where programming is used. So there's a lot of different fields that programming becomes important in. Some of them are the ones that you'd be familiar with, like mobile devices and the internet. Other ones might be a little bit more abstract. Business applications, warehouse automation, and robotics. So with mobile devices, every one of our devices, our phones, our computers, everything runs on software, and that software is going to be used to be able to capture input. So anytime you tap on the screen or you type on the computer, your computer is capturing that input and doing something with it, and then giving back some output. So when it's displaying something to you on the screen, or your Alexa device is speaking something back to you, your computer is basically processing input and returning output. So our mobile devices have software that needs to be programmed to do this in order to allow our phones and other devices to be able to do the things that we expect them to do. Business applications, there's a lot of different programs that are going to be used by accountants within retail stores. Anytime that you go into a retail store and you see somebody scanning something at the checkout, or they're putting something into a portable device, basically what it is that they're doing is they're interfacing with some sort of a inventory system that's going to use a computer to keep track of all the products that they have in stock. So they know what they need to order, they know what they have extra stock of that maybe they want to put on sale, and it allows them to kind of keep diligent records. Warehouses often have the same type of systems for inventory control. Accountants use different types of accounting software and tax preparation software for managing people's finances. There's several different business applications for programming that utilize a lot of these same programming languages. I myself work in a bank where we have tremendous repositories of data that all need to be processed by software that needs to be run on a day-to-day basis. Factory automation is another big one. A lot of factories run specifically on using robotic arms and other types of machinery that needs to be programmed so that it can do these type of repetitive tasks over and over again. So if you have a car manufacturer or any sort of a facility that needs to be able to produce things in mass scale, we're going to need to write software that's going to actually mass produce these type of things. So oftentimes this helps because these are tasks that maybe a human couldn't do because that would require them to be able to lift things, or even if a human could do them without the aid of robots and computers, it would be far more time consuming, and this allows things to be done much faster and more efficiently. And robotics is definitely a place where programming has a specific need, because robots obviously cannot think on their own. They need software that is going to give it instructions on what it is that it's supposed to do. So if you think about robots that are used to disarm bombs, or robots that are used for within manufacturing, all of these need to be programmed in order to work as efficiently as possible. And lastly, there's the internet. So everything that you look at on the internet needs to be programmed. We looked a little bit at this yesterday, and programming the websites is really the only way to be able to give the user the ability to control what it is that they're seeing on the screen and interact with it, and be able to actually make the software that they have in front of them, whether it's a banking application or an email application, to actually have it respond to button clicks and other things that make the website interactive. So those are some of the different types of devices that need to be programmed. Now what we're going to do is we're actually going to take a look at another programming language. So yesterday we looked at JavaScript. Today we're going to be looking at Python. And we're going to try to get through requirement 5B here, which is going to have us write, debug, and demonstrate a functioning program. So we're going to go ahead and we're going to build an ATM. And I have here a link to the program that I built out as a sample. And just before we get into that, I want to take a look at a flowchart. So let's think about what an ATM would do. Just the most basic ATM is going to have three main functions. It's going to allow you to check your balance, it's going to allow you to make a withdrawal, and it's going to allow you to make a deposit. Checking a balance really only is going to do one thing. It's going to display your balance. Making a withdrawal is going to ask for the withdrawal amount. It's going to check to see if you actually have enough money to withdraw that. If not, so you see that diamond there where it says do they have enough, is a condition that's checking to see if they do or do not have enough money to make that transaction. If they don't, the program terminates. If they do, it will withdraw the funds, and then it'll display the new balance. And finally, if we make a deposit, it is going to add funds to the balance, and then it's going to display the new balance. And this is going to be a loop, because every time you do one of these interactions, it is going to continue to ask you if you want to do another action before the program terminates and it exits the user altogether. So let's take a look at a sample program that I've written up here. And again, this is written in Python, which is a scripting language. And we're going to set a couple of variables up here at top. So we have three variables called name, balance, and choice. Name is the name of the person who's using the ATM. You can change this to whatever you want. And the balance is however much money you have starting when you enter into the application. We can change that to whatever we want. And choice is just a variable that we're going to use in our conditional operators. And then you see here we have our main loop. It is a while loop. A while loop is a type of loop that will continue to iterate over and over again until some condition is met. In this case, we're going to continue to iterate as long as choice does not equal 9. This exclamation point equals is a not operator in Python, and it's going to continue to run our program until somebody puts in the option 9. Then we're going to print some things out to the screen. We're going to print out welcome to ATM, and then we're going to print out the person's name. That's the name that we set up here in our variable. And then we're going to ask them what they want help with today. Check their balance, which would be 1, make a withdrawal 2, make a deposit 3, or exit 9. We're going to wait for their input. Remember I said that every program is going to have inputs and outputs, so we're going to wait for input from the keyboard, and then they're going to make a choice. And then we have our conditional statements here based on the choices that they make. So if they choose 1, we're just going to print back what their current balance is, and that balance is going to be coming from this variable that we defined up top. Then we have an else if, so this tells us if this first choice is not met, check this next choice, and if this choice is met, which is 2, which is make a withdrawal, remember our flowchart, we were going to ask how much they want to withdraw. We're going to, and that's going to be taken in as an input, and then we're going to compare that value that they just put in. Because it gets input as a string, I have to convert it to an int here. Int stands for integer. And we're going to compare that withdrawal amount to the balance. And if the balance is greater than the withdrawal amount, see we have this less than sign here, so if withdrawal amount is less than balance, then we take balance and we subtract the withdrawal amount. And then, again, back to the flowchart, we print out what the new balance is. If they do not have enough, then we just print out that they don't have enough funds. Finally, we have our last else if here, our second to last else if here for the choice of 3, which is going to take a deposit amount, which is going to be, again, we're setting a variable here for deposit amount, which is going to take an input that asks for how much they'd like to deposit, and then we're going to take their balance and we're going to add that deposit amount to their balance, and then back to the flowchart again, we're going to print their balance back to them. And then finally, we have our last else if, which is to check to see if they entered in the value 9. Remember, 9 was to exit. They enter in the value 9, and it's going to print out have a nice day. And after that, it will exit the application. If they entered in anything other than these values, it's going to hit this else statement, which is basically a default, which is going to print out a command that says, I don't recognize that command. And then since this is a loop, it's going to loop right back to the top. Because of the way that Python is structured, it's always going to use indentation to indicate that a particular subsection of the program. So this while loop, everything underneath this while loop is all indented. So that means all the way until the end of this last line here, line 40, is all part of this while loop. So after this command, it's going to go back up to the top here. And as long as the value that they entered in isn't 9, it's going to run through the loop one more time. So let's run this program. And it's going to say, welcome to the ATM, Brian Gregg. Remember, we set the name equal to Brian Gregg. And it's going to allow us to do one of those 4 options. So we can check our balance. It's going to say your current balance is 1,000. We can make a withdrawal. It's going to ask us how much we want to withdraw. If I said $5,000, that is not enough, so we don't have enough funds in our account, so it tells us. If I make a withdrawal and I put in an amount that is within how much we have, it gives me back what my new balance is, which is 200, and it brings me back to the top of the loop. If we make a deposit, it asks me how much I'd like to deposit, $800. And here it tells us what our new balance is, which was the 900 plus the 800 we just deposited for a total of 1,700. And finally, we can exit, which gives us that closing message that says, have a nice day, goes back to the top of our while loop. It abends because choice is equal to 9, so this while condition is no longer met, so it exits out of the program altogether. So I'd like you to take this program and play around with it a little bit yourself. Use the debugging tools. So if we made a mistake here, and let's say instead of putting elif, I put else if, not realizing that that's not proper syntax, and I hit debug, it's going to tell me right here that there is an error. Else if choice equals 2. Syntax error. Invalid syntax. So right there it's telling me exactly where in my program, line 24, so I can go up here and I can look at line 24. It says line 24, there's an error on the else if invalid syntax. Oh, that's right, that's not correct. So we go ahead and we stop the program. We change that back to an elif. We run the program, and ta-da, everything's working as expected. I hope this was helpful. Again, we're going to give you a chance to go and play around with some of this yourself and take a look at the sample code that's out there on online GDB that I put out there to work off of, and we can take a look at what you come up with. I'd like to see you come up with maybe another program that does something similar. Feel free to reach out to me if you need ideas. All right, thanks everyone, and good night. Stay safe.